Okay, good morning. This is the last lecture of this course. So week 12, lecture 2, and my plan today is to do a sample final exam from my previous years. Now remember, the exam will cover everything after the midterm, and here is a sample, and only a sample test, which has 3 problems on it. Now remember, 25 marks also are given for the multiple choice short answer questions, which is not reflected in this document that I'm going to show you. So there's 25 marks for the multiple choice, no part marks there, and 25 marks, 3 of them equally weighted, obviously, for this portion of the software portion of the final exam. Now, the first problem, let me quickly go through what they are. The first problem is a typical single degree of freedom kind of dynamic problem, and you're asked to, or kinematic problem, you're asked to find, animate the mechanism and put some laws in it, and then plot the trace of something, trace of this point, I believe, and also give some information about velocity or kinematic information, such as velocity of a point, such as the point A, and the acceleration, etc. The second problem is a design table problem. And the last one is something that you decide on your own what the dimensions should be and animate this particular garage door, for example. Okay? All right, let's go ahead here. Now, you're told that this wheel is rolling on that track. So basically, we're going to make a roll curve joint between the arc of this, or the circle of this wheel and that edge. Okay, and the diameter of this wheel, only critical information is given. For example, some of the other stuff here, there are no dimensions on it. You have to decide by yourself because they have nothing to do with the kinematics of the problem. Okay, so let me see. The diameter of this is 10 inches. So that, by looking at this diagram, maybe I should make this track maybe 30 inches long. Okay, 30 inches long. All right, so let's go ahead and start with, this is going to be a wall, big arm, small arm, and wheel. All right, let's go ahead and do that. Product. Immediately save it, file, save management, save as. I have a folder called review, desktop, August 1, no, August, maybe review something, desktop, there. Okay, so I'll make a folder here, problem 1. Problem 1. All right, let's make the wall. So insert a new part in there. And I'm going to call this thing the wall. Right click properties, wall, and wall. Okay, let's make it. So on that vertical plane, I will sketch a rectangle. Let me see now, a rectangle like that. Let's give some dimensions here. Remember, this is roughly, I wanted this thing to be 30 inches. So why don't I make this thing 30 inches? Right now it's 8, so I'll make it 25 inches. And obviously this height is now going to be also about 30 inches. If necessary, I will cut the size of this so that it doesn't take too much space. Okay, good. Exit. Pad it. Let me pad this thing by 1 inch. That's how it looks like. Actually, let's make it more. Why is it stuck? Okay, so make it 4 inches. How about that? Yeah, that's good. So on that face, I will. So maybe yeah. Let me see now. On that face, I will sketch a line that's at 20 degrees. So I'll fix that in a minute. You'll see what I want to do. Okay, so the only thing is that this angle between that line and this should be 20 degrees to represent that diagram that I have. Now I'll bring this thing, oops, Control Z. Okay, let's change this thing 20. Okay, good. So let me see now. I'll bring this thing down. Yeah, something like that. Maybe this down a little bit also. Good. Now, just make it vertical. Although it really doesn't matter. This is 20 degrees. That's all I need. So exit, and I make a pocket of 2 inches. So you can see what I wanted, what the plan was. As far as making that shape is concerned. Now, let me see now. There is a little pin here. So let's go ahead and make it roughly at this location. Make a circle. Something like that. Exit. And then pad it. I'll make it 1. All right. Good. So this takes care of the wall. Okay. All right. Now we're going to go there. Insert. Let's do the big arm. So insert new part. Going all the way on top. Insert new part. Say no. Right click properties. And I'm going to make this thing big arm. Let me see. A big arm. Okay. Same thing here. Big arm. Let's make it. So let me do that. On that face, I will sketch. Why don't I project that circle? There. Normal view. Now let's do that. For example, the rectangular piece. Okay, so I'll do the elongated hole, and I'll clean it up in a minute. Okay, good. Now I want this and that to be concentric. Control. Concentric. Okay, that's good. And exit and pad it by 1. Okay, now notice that there is a cutout here. There is a cutout here. So on that face, on that side face, on that side plane, I will sketch. What am I looking at here? Oh yeah, this is the piece that I want. So let's go, this is the piece that I want. Why don't I make a rectangle? And what I will do is to make the distance from here to be half an inch, just so I have a better control over what I'm doing. So from here to there, yeah, 0.5, yeah, 0.5. Exit, exit, and make a pocket. The other direction, see for a second. The other direction, reverse side. No, not side, reverse direction. That's what I meant, not side. Let me see. This may not come out to be what I want, so let me. Yeah, we'll check it out. If it doesn't look good, we're going to change it all the way to the end. And for this piece, yeah, so let me also start it further to the right, the other way. Okay, that's good. Let's see, does that look good? Yeah, it looks good. It's not symmetric, but it doesn't matter. That doesn't change the mechanism. However, if I want to make it look a little nicer, double click. Okay, move this thing a little bit down. I think that probably makes it more. Yeah, good. All right, so let's go ahead and make the small arm. So we're going to go all the way to the top. Save everything. On that face, I will sketch. Oh, sorry. Be careful. Insert, new part in there. We call it small arm. Small arm. Small arm. Say okay. Make it. So on that face, I will sketch. Why don't I actually? What is this? Oh, look at the other side. Look at turn this thing around. Look at the other side. There. Okay. So why don't I project these three curves? Yeah. So actually, I can project these four curves. How about that? Yeah. So we're gonna do project this edge, this edge. We can do it all at the same time, but and that edge. Okay, good. Exit, pad it in the other direction by 0.5. 0.5. There we are. And if you go all the way, you also want a little circle here, little hole there, right? So on that face, I will sketch actually. Why don't I go back to that sketch? No, not this one. The one that I was just doing. This guy and the pad, right? Go to that sketch. Draw a little. Yeah, draw a little circle there. Let me give it a dimension. 0.5, radius 0.5. Okay, exit. There we are. And if you go all the way to the top, and move this thing a little bit so that I can see what's going on. There we are. This is the small arm. And hopefully this can reach, that end can reach this. Let's check. I think it can. I'm pretty sure it can. Okay, good. Now the wheel. So we go all the way to the top. Insert, new part. We're going to call it the wheel. Okay, and the easiest place to make it is probably that surface. Let's go make it actually, double click on it. On that face, I will sketch a circle, radius 5 inches, right? So let's give this thing 5 inches, radius 5. Okay, so that's going to be the wheel. All right, let me see for a second. Radius of 5, okay, fine. So let's see, how is that? There's a hole, there's a spoke here, and there's a little hole there. Okay, so let's make this thing, and that's supposed to go, this hole is supposed to go into that spoke. So why don't I make that radius 0.5, so that these are kind of almost the same size. And then I will make a circle over there, and the distance from that center, the distance from the center of this to the center of that is 4.5. Right there, you can see that this is 4.5. So dimension from that to this, 4.5. That's where the sensor is going to be placed. I'll make this thing a little bit smaller. Okay, good. Exit, pad it. Okay, actually, because I want this thing to be not to be a hole, why don't I do a multipad here? Multipad. So that is the small circle here. I'll leave it at 0. It's going to be a hole. This is that guy. Why don't I make this thing 1 right now? We'll see how it looks like. Maybe 2. And then this is the actual wheel, and I'm going to make that thing 1. Okay. Later on, this is going to be later on, this spoke is going to go into that hole, and this is going to be flush with that surface. I mean, we may have to make some changes here. Oh, actually, you know what? I could have made this thing bigger. Yeah, actually, let me go ahead and make these things a little bit bigger. So let's go back there under multipath. So that guy, I'm going to make this maybe 4. Preview. Okay, fine. This is that hole. I'm going to leave it the way it is. And this, I'm going to make it 2. Yeah. Okay, that looks probably a little better. I may have to go and change these things, make them longer, etc. But yeah, particularly this one. But then the problem is that because I projected that, let me go to this, make that guy a little bit longer. So where was this? This thing was in the big arm, right? Big arm. It was right here, I believe. Yeah. So why don't I make this dimension bigger? How about 16? Maybe 18. Exit. Let's see what we got here. Let me see. Go all the way to the top. Move this guy out because I want to see how it looks like now. Oh yeah. So that obviously I have to fix it. This one I have to fix. Cancel. Go back to that same sketch. It's the pocket. That the length of that pocket I have to adjust. Was it? Yeah, the length of that pocket. Not this one. Cancel. Cancel. A big arm. Big arm. Big arm. This pocket. I'll make a further back. Good. Now you can see it's okay. Go all the way to the top. And if you move this thing, you see that much better. Okay, good, good. So let's go ahead to product, save everything, and we're going to do assembly constraints now. Okay. Move things apart. First of all, let's anchor the wall. Move things apart. So this one, let's move it in the X direction, X direction, X direction. We keep that there. Okay. First of all, let's make this thing tangent to that, and we do that by contact. Bring it down, so that face and this face, and it's going to be external. Okay, update, it pushes it up. You see that? Good. Now let's put this guy in there. So coincidence between this axis and that axis, and coincidence between, for example, this plane and that plane. Try it again. I don't think I did it. How many constraints do you have so far? Axis to axis. Okay, another one. Coincidence between this plane and this plane. Update. Oh, so let me see now. Something I screwed up here. Let's get rid of these two. Delete and delete. Move this thing out again. Move this guy out. Try it again. Coincidence between this axis and that axis, and coincidence between this plane and that plane. Update. Good. That's going to become a revolution. Now put this thing in there to make it prismatic. Coincidence between, for example, this face and that face, and coincidence between maybe this edge and that edge. Update. Okay, very good. That is a prismatic joint. Let's move it back so that it looks, from the visual point of view, looks more appealing. Right there. All right, now we want to put that hole, that spoke inside of that hole. Coincidence between this axis and that axis. That's going to become a cylindrical joint later on. And update. What happened to the wheel? Hang in there. Undo that. Okay, so let's do the following. Let me move this thing up, rotate this thing. I'm going to rotate it about that axis. Respect the constraints. Where's that? Hang in there. Where did, oh, right there. Something is not, oh, this axis and that axis. So there is a problem here. Let me delete this, rotate about that, keep the constraints active. Okay, let me see. Yeah, so let's try it. Coincidence between this axis and that axis. Good. Hey, you gotta work on it. Now, let's save everything. Let's check to see if it's working. So move, manipulate, check this box, and then let's rotate about this axis. Find out. Yeah, see, that's the way it's supposed to be, right? That's the way it's supposed to be. So I'll start at this end. Good, everything is okay. Now we're going to go and create our joint. So digital mockup, DMU kinematics, get the magic wand out. New mechanism, auto create. Okay, so let's check out. There should be one revolute, one prismatic, one cylindrical, at least, maybe other ones. Prismatic, revolute, cylindrical. The revolute is here. The prismatic is because this guy slides up and down the big R. And the cylindrical is because I made the axis to axis. Now, a degree of freedom is 4, so I need a roll curve joint. There's a roll curve between this edge and that edge. And say, okay, degree of freedom is 1. So now the question is, if you are giving the speed of this, and that's what the problem is saying, it says, suppose that the wheel is rolling angular velocity of 10 RPM. So if there was a motor there, for example, it'll cause a 10 RPM of this. Okay, so what we're going to do is we're going to make this thing angle driven. That length, that cylindrical joint, we're going to make it angle driven. Double click on it. Angle driven. Say okay. Of course, mechanism can be simulated. And now, what do we have to do? Is the mechanism functioning correctly? So let's see now. It better be, it should be. I mean, we already checked it. You can see that. See that? It is functioning correctly. Okay. So that's for part marks there. What else do we have here? It's generate the trace of the point A and display it. Okay. So we know how to do these things because this is single degree of freedom system. So I'm going to go and create a simulation. Drag it there. Oh, yes, drag it there. Yeah. Let me reset, try again. So insert, rewind, and we can play it. Slow it down. Okay. So we created a simulation here, you can see that. Now we're going to compile it. Create a replay, not at that speed, say okay. Good. And then the trace is done with going to this fellow here, right there. You see that trace? It says the element to trace is that point. Unfortunately, I forgot to create my point. So let's go to the wheel here. go to the wheel and create a point right at the center of that. Right there. Okay, now we're going to go back to our DMU. Okay, and click on the trace. Element to trace is that point. Reference product is 1. Say OK. Where is it? Fit. Yeah, it's right there. Okay, make sure you save it. File, save management, save as, in that folder, which was called August review August 3rd, in problem 1. Say OK. I can close it. Let's check it out, make sure everything is there. Not this. Where is the review thingy? August 3rd, right? Right there. Yeah, the trace is there. Very good. What's the next thing? It says, let's assume that there's a mistake here. There's a typo there. Let's use 30 RPM. This is a typo. This should be 30. Okay, so let's go there. And okay, so how do we put physics into this? So click on the f of x. Click on f of x. Click on mechanism. There. Here's the command. Add the formula. Now 30 RPM is 180 degrees per second. 180 DEG underscore second times time. Okay. Now what's the duration of the simulation? 6 seconds. All right, let's try it. So where is that? Let's create a sensor at that location, by the way, because it says show me the magnitude of the velocity, which means basically no x, y, z component, just magnitude. And let's do this thing at the point A, right? So, and magnitude of linear acceleration versus linear velocity. Okay, so what we have to do is create a sensor for that location. Reference product is the base. The point is right there, not the wall. Oh yeah, point. Good. Okay. And then click on the simulation with laws. 6 seconds. Okay. Activate sensor. What do you want? Linear speed, which means the magnitude. This is yes. Linear acceleration, which means the magnitude. Scroll, move this thing out of the way. And what I actually, yeah, okay. So for the first one, for the velocity versus time, I don't want linear acceleration. So I uncheck that, just linear speed right there. Okay. And play it. Okay. And graph it. Okay. And then save it. Notice that 6 seconds was too much. Actually reaches the end. But that's what I asked for. You go ahead and do that. I zoom out so that I can see the units here. So print screen. print screen, a Word document, or JPEG, save it, file, sorry, paste it, I mean. There we are, save it, file, save as, that folder, browse, that folder was called August, review August, review, right? You joined. I'm pretty sure I had a folder there by that name. That's where I put my stuff in it. August 1. It's impossible. Oh, review right there. So velocity versus time. Okay, here it is. I can close that. I can close this, rewind it, and now I ask for also linear acceleration. Where is the acceleration? Linear acceleration. Okay, and okay, so play. By the way, I'm not sure if I cleared the history or not, so I'm going to clear the history and then play it. When it gets to the end, graphics, but that's not what I want. No problem. Options, customize plot. And for customized plot, I want add. I want linear velocity, which I asked for, linear speed, versus linear acceleration, which I asked for. Right there. And then I say OK. And then that's this curve. Close and graph. And there we are. Okay. Zoom out so I can see your units. Print screen. Go to your Word. I'm creating a separate file. So paste. File. Save as. It was problem 1, right? Yeah, it was right here. And I'm going to call this thing speed versus acceleration. And then you say save, and you close, and you close. You're done with this problem. Yep. Okay. So let's check our folder, make sure everything is good. Don't forget to save everything. That folder that you're going to upload, if you were doing this, would have your product, 4 parts, the trace, and the 2 plots that you generated. Okay. So now we're going to go to problem 2, which is a design table problem. Okay, so here is the Excel spreadsheet that I've already prepared, and This is a design table problem, so I have for a part, so I can do. This says respect all the information is given here. These have to be parallel. These have to be perpendicular. There has to be a symmetry line. So I can do half of this and then mirror it, and that's the approach that I'm going to take. Let's get through this. Start with the part file. So on that vertical plane, I will sketch. Let me see now. What do we have here? Let me do this piece first. Okay, so maybe like that. Oops. Then it says these have to be parallel. So there we are. Okay, and then the arc. I'll do it like that. And I want the center of the arc to be on that line. So that'll do it. Okay. So let us mirror these things. By the way, yeah, okay. So let me mirror these things. This, control that, control this, control that, and that. Mirror. Okay. Let's dimension these. And I'm going to use these first row here. So there is an angle up there, 75 degrees. Radius is 2. Okay, and this is 3, and this is 2. Okay. So let's check. Let's go and use these same values. This is supposed to be 2. Let me change that thing to 2. This is supposed to be 3. Let me change that thing to 3. Okay, radius is supposed to be what is it? 2. Okay. And this angle between this guy and this guy is supposed to be 75. Okay. Let me change that thing to 75. So I'm not very far. It was not very far actually. Good. That's pretty much it. Is there anything else? I don't think so. All right. So exit, padded. This is, you're told that this is 2, 1 inch actually. So we make it 1. All right. So let's go and create our parameters. Oh, material. Apply a dummy material to it. Right there. Aluminum. Okay. The only thing is that when you look at the table, the name for the material is my mat, and we know how to fix that. So, for example, you can go, if you want, you can go to the different ways of doing it. One is you can go here, double click on it, and change this thing to my mat. Or you could have gone to f of x and find the I already changed it, but you could have found this, could have changed it right here. I already changed it, so it doesn't need it. Now, what are the parameters? There's 3 length and 1, how many? Angle, right? Length, and angle. Okay, so let's do that. So let's go ahead and make length first. One of them is called R, and the value of R was in that first row was 2. Another one was W, and the value of W was also 2 in that row. Another one is D, and I think D was 3. D was 3. Okay, apply. And now we have an angle, alpha, and it is 75 degrees. Good. Oh, serial number. Change this into string, not boolean, string, and serial number, SER number. And we call it some dummy. Okay, good. Now, we have to create our equations. You click on the part, anything that you want appears. So I want this thing, add a formula to be D. That guy, add the formula to be W. This is the radius, add a formula equal to R. This is the angle, add the formula equal to alpha. Okay, and find the part number. Part number. Here's the part number right there. Add the formula equal to serial number and say OK. Now you can check, for example, if you make this angle alpha 60, does it change? Yeah, it does change. Okay, you can. This is W is this side. This side. Let's make it a 4. Yeah. Okay, it's changing. Good. Good. So now we're going to do the design table. Okay. So let's make sure to save this thing. File, save management, save as. Oh, once again, we're back to this. Review, right? Ah, there we are. Okay. And I'll call problem 2. New folder, problem 2. All right. Good. Let's go and get the sky design table. I already created one, which was in review. There we are. It says, should I automatically associate? Yes. Everything is done, material. So if you go, for example, to this guy, this is already the one that we have. But you can see that the material changed, serial number changed. And if you go to the next one, okay, again, material change, serial number change, and the dimension change. And this takes care of that problem. Do not forget that when you submit your work, put that review, this spreadsheet in your folder, right there. Okay, the final problem that we're going to do is this garage door. This other side is totally useless. Okay, just sitting there. If you can make it, but these are 4 panels. You know, I'm going to make 3 panels for you. Okay, I'm going to make 3 panels. If I can do 3, I can do 4. Okay, so let's go ahead and make it. Obviously, it's a mechanism, product. Let me make the frame yeah, how about the railing? Okay, so insert new part in there. And I'm going to call the track. How about call it track? Properties track. And track. Take it. On that vertical plane, I will sketch something that resembles that track. Is that good? exit, pad. There's my track. Okay, I'm going to make 3 panels, panels 1, 2, and 3. Okay, now, you know what? What I would like to do is I would like to get a curve here, a curve that looks like that track, because the problem is that this is, if I do it without that curve, I'm going to have this track, these panels are going to stop right there. They're not going to go around the bed. So what I'm going to do is I will go to generative shape design. Okay, for example, oops, not there. Generative, where am I? Okay, sorry. Let's go to the track. Let's go back to the track. Go to generative shape design, already there, and extract these side faces. Okay, extract these. Where's the extract thingy? Extract. Right there, see that? Or was it right there? You remember that guy? So this edge and that edge, well, say, okay, if you want to do multiple of them, here's another one, and here is another one. You say okay, you say okay, and I'm going to join these 3. Okay, join these. 1, 2, 3. So it's going to be a single curve. Okay. Now let's go all the way to the top. I set the top panel. So insert, new part, I'll call part 1. Okay, panel, that's going to be panel 1. I don't have to rename it. Double click, and all it is a box basically. So on that vertical plane, I will sketch a box just to make my job easier. You know what? I'm going to make that, give it a size. That's just to make my job easier. Okay. Where is the dimension? I can't find my my dimensions here, so maybe I closed it. Right click, constraints, right? Constraints. It says it's there, but I can't find it. Okay, so let's do this. Let me see that. Measure, constraint. Maybe it was hiding behind that. Oh, try it again. Right click, constraint. Oh, yeah, it was right there. Okay, so let me make this thing 7. And this thing maybe maybe 1. Exit, pad it. Obviously, you have to be in part design to pad it. I'll make this thing 0.5, 0.4. So that's one of the panels. Another one, insert, new part. Where is that? Insert, new part in there. And that's going to be middle panel. Okay, let's make it. Double click. Exactly like that on that vertical plane. I will sketch. And this is why I actually gave dimensions there so that I can quickly make one. So this was 1. And this was 7. Exit. Add it. I think it was 0.3, 0.2. Okay, maybe I'll make this thing also 0.2. How about that? 0.2. So that they look the same. Okay, good. Third one, insert new part in there. This is the bottom panel. On that vertical plane, I will sketch. Seven. One. Exit. And add it. 0.2. Good. We're done. All right. So save everything. File. Save management. Save as. Make a folder here. Problem 3. Put the stuff in there. Okay, let's go and do our assembly constraints. I don't need any of these. I just hide them. So we go to assembly constraints. Anchor the this guy, the track I call it. Okay, so notice that these are revolutes. These are revolutes. Okay, so let me make a coincidence. It is possible to do it a different way, but let me make them revolute. Okay, this and that, and coincidence between this plane and that plane. We say update, they go together. Okay, do the same thing. Coincidence between. Let me see for a second. I'm not sure which one I actually. This coincidence that I put was between which two edges? Let me see for a second. I made these two edges. Okay. I really wanted to make it between the other two. Cancel that. So let me delete that. Actually, that's okay. That's let me see now this thing. Yeah, that's fine. That's fine. So let's do it coincidence between we'll do exactly the same thing. This edge and that edge. And coincidence between this plane and this plane. Okay. Update. There we are. Okay. Now I want to put this, I want to bring it and put it against that wall. So let's say coincidence between this plane and that plane. Okay. Okay, and I want to bring this and put it on that curve, for example. So for now, we're going to do it like that. Coincidence between this point and, let me hide this. Maybe I better put it on this point right now. It really doesn't matter. We're going to fix that later. So let me do the following. I'm going to move all of these down. So move this in the direction Z. Oops, not rotation. One down. Okay, and now we do coincidence between this point and that edge. And let's update. Good, good. Okay, very good. Now, so notice we're going to have 3 revolute joints and 1 planar joint. This is fine. And we have to do the rest. Okay, so let's go ahead to the digital markup, DMU kinematics, get the magic wand out, new mechanism, auto create, you say okay. And there will be some joints, there will be 3 revolutes probably. Well, there will be revolute, that's okay. Yeah, 2 revolute, these 2 revolutes and 1 cylindrical. Now that cylindrical I'm going to delete between the track, delete. I'll show you what my plan is. Okay, so there is a curve here, right? Where is this guy? There is a curve here, which I hit. That joint, can't remember, where is that joint that I hit? It was in, where did I join these things? In the track, right? Right. I didn't show, so let's check it. Right there, you can see that. All right, so I will do a point curve joint between, the curve is that joint, and the point is that point. Now, if I have a hard time picking it, let me hide these things. Let me hide that. This point, okay? That's one. Another one, another point curve joint between that same joint curve, joint curve, and for the point, we take one of these, doesn't matter which one, because there's 2 on top of each other, and another one between that joint and again this point, okay, and finally another one between the joint and this point. Let's see what the degree of freedom is now. Degree of freedom is 2. Okay, very good. Now, we want one of these panels to be on top of that track that I hit. So let me bring this thing, let me do it now. We say planar joint. Is that the planar one? Planar joint between this and, let me see now, and that. Okay, so let's see, degree of freedom is 1, no problem. All right. Okay, so the degree of freedom is 1. I will make one of these point curve joints length driven. Where's the track, by the way? The track is hiding. Yeah, it looks like that, right? One of these point curve joints, and it really doesn't matter, I'll use the first one, length driven, in the other direction, maybe. Mechanism can be simulated. So let's go do that manually first. And that's all I want really. I want right there. So you see this? You see this? And then it can be cleaned up. A 4th panel would have been exactly the same. So, all right. That takes care of this. Yep. Remember, this is the final exam. It's a stressful course because it's tough. I mean, I understand that. You should have worked. You should have done all your homework, all your work during the semester. So my advice to you would be, first of all, try to make the parts so that in case, God forbid, nothing works, at least you get some part marks, okay? And then I'll try to be as lenient as possible, but the ball is in your court now. Good luck and see you tomorrow in the lab.